Introduction to exercise 1B on decimals and significant figures on page 9 of the textbook. For our junior question, we said which is more accurate and why 8.49 or 8.5. Technically speaking, you can argue both sides, right? Accurate, in this case, accurate to what? However, normally speaking, the more decimal places you have, the more accurate it is. Right? In this scenario, 8.49 would be quote-unquote more accurate than 8.5. If you had a scale, for example, a kitchen scale, it might go to 100 grams, and you can measure maybe 115 grams. You might even be able to measure 115.3 grams, but it wouldn't be as accurate as some equipment you use in a lab, where you can get to 115.363 grams. Yeah? So the more decimal places, generally speaking, means that it's more accurate. Okay, now for today we're going to be rounding to two types. We're going to round to decimal places, which for most of us we're already experts at. The tricky part for us is the significant figures. However, I am going to cover how to do decimal places first, so that we're all on the same page. If you haven't finished copying down these steps, I definitely recommend you doing so while I'm speaking. For rounding decimal places, it's pretty straightforward. You already know the process for this. First step is to find the digit in the specified number of decimal places. Anytime you're asked to round, it always tells you round to X number of decimal places. So for example, 2 or 4, whatever it is. In this case, we're rounding to 2 decimal places off the chair. Thank you. If the number afterwards is 0 to 4, you round down. If it's 5 to 9, you round up. Pretty straightforward. So in this case, 138.4681. I'm looking for the digit in the specified number. It says to 2 decimal places. So the second decimal place is right here. That's the 6. I look at the number after. The number after is 8, which is between 5 and 9. Therefore, we round up, so it becomes 138.47. Does anyone know which symbol I use in between these two? Because they're not technically the same thing, are they? Does anyone remember what the symbol I use to show that it's not exactly equal, but it's about the same?
Like 2 squiggly.
Perfect. 2 squiggly lines, the approximate symbol. So 138.4681 is approximately 138.47. Now for you and me, in almost every scenario in our lives, we don't really need more than 2 decimal places. Right? However, if you're working with very, for example, dangerous chemicals, or you're working with very high safety protocol chemicals, you're going to need to make sure that it's the right number of decimal places. 138.47 is technically more than you need if you need exactly 138.4681. Yeah? And for example, if you're doing measurements, so you're building a shed or whatever it is, if you're looking at meters, 1.3 meters is drastically different from 1.34 meters, isn't it? Yeah? In the next example, it says 0.03268. I look for the digit in this specified number, in this case 2 decimal places. So that's this one right there. Look at the number afterwards. It's a 2. Therefore, I round down to 0.03. Any questions before we move on to the significant figures? Pretty happy with our decimal places? Okay. Significant figures are a little bit different. Okay? They're a little bit different because we don't normally use these in our quote-unquote everyday life. It's not as common, right? To round to significant figures, we have to do, again, 2 steps. One, find the first non-zero digit from the left. So we always look left to right. Anytime we do graphing or writing or whatever it is, left to right. From there, count the number of specified digits. So it's saying, for example, if it says 3 to significant figures, we count 3. Including 0, and round this last digit. Okay, that's it. So let's put that into practice. It's a lot easier than it sounds. The question says, round each of these numbers to 2 significant figures. This one's pretty easy. Find the first non-zero digit. From the left, of course, that's 2. I need to count from there, count the number of specified digits, so that's 1, and then that's 2. So the second significant figure would be the 5. Any questions about that? Okay. From there, count the number. We've done that and round this last digit. So 2, 5, 6, 7. The number or the digit after 5 is 6. So we round up and that becomes 2600. And again, I'm going to use that approximate sign. You see how for our number, it is different, but it's a little bit easier of a picture to understand. So for example, if I was measuring the length of the classroom and it was 2,567 centimeters, I might just say 2,600 centimeters. Yeah. So rounding to two significant figures. Even though there are zeros and there are technically more than two figures, the 2 and the 6 are significant. They give us information. For this next one, we've got 23,067.453. Again, first step is to find the first non-zero digit. In this case, again, it's just the first digit, 2. I'm going to count. I know that 3 is our second significant digit. So then I round. The digit after that is 0, so I keep it down to approximately 23000. So that's about the same. I'm pretty happy. The next one here with the decimals is what I want to focus on. This is where that first step actually comes into play. If I said the first non-zero digit, that would not be the first 0, but it would actually be this 4 right there. I look at the digit after that, 0. So that would be my second significant figure. The digit after that is a 5. So I round up. And that's approximately 0.041. Again, note the fact I only have 2 non-zero digits in my answer. Every single time there is 2 non-zero digits. And that's what it means to have 2 significant figures. Any questions about that? Okay. The reason why you might want to use significant figures over rounding decimal places is because it works for very big numbers as well. Okay, now in this case, I'm going to do one more example, then I'll get you to get started with some practice questions. It says, estimate the answer to the following by rounding each number in the problem to one significant figure. So, 19, what's that about? 19's about what? 20, thank you very much. Now with this 2,143.1, let's fix that up. How do I change it so it's only got one significant figure? It's only got one digit at the front that's not a 0. It's closest to, thank you very much, 2,000. And then I'm going to times it by that one right there. Instead of writing 0.0032, I'm just going to keep it at 0.003. Okay? And then you can approximate it to get a closer answer. Any questions? Okay. What I'd like you to do